What is a black hole? A black hole is an object in space that has been compacted so tightly that the density is so great that the escape velocity is greater than the speed of light, which is 300 million meters per second. Black holes are so dark that no one can see them. Dark is not really a word that can be used to describe a black hole, as they are actually more like invisible, as the light that would be coming from the black hole is not able to escape. Therefore, it cannot reach us and we cannot perceive that region of space. How are black holes created? There are three types of black holes. The first one is a stellar mass black hole. These black holes are formed when massive stars die and go supernova. Another type of black hole is supermassive black holes. These black holes lie in the center of galaxies and we don't really know how they were formed. It has been theorized that they were created sometime around the time the galaxy they were in was formed. The third type of black hole is miniature black holes. These black holes form when something smaller than the Sun gets compressed past its Schwarzschild radius. Once something gets compressed past its Schwarzschild radius, its escape velocity will be so great that light will not be able to escape. Misconceptions. There are many misconceptions about a black hole, such as a black hole has a very large volume. This is false, as density is mass divided by volume, and a large volume does not allow for a high density, which does not result in a black hole. A black hole has no mass. This is false as well for the same reason as the previous one. With a low mass, there is less to be divided, resulting in a lower density, which will not result in a black hole. Our Sun will become a black hole. This too is false, as our Sun does not have enough mass. When a star dies, it begins to collapse. If there is not enough mass in the collapse, then it will not hit its Schwarzschild radius. Our Sun will turn into a white dwarf star, which is very dense, however, not as dense as the black hole, and will remain visible. The biggest misconception is that black holes will eventually suck in the entire universe. This is not true at all. It is true that when stars come close to a black hole, they can get violently shredded in what is known as a quasar. However, those stars are already on a crash course with that black hole, not pulled in. Black holes do not exert stronger gravitational waves than the stars before them produced. Therefore, there is no sucking action from the black hole. When near a supermassive black hole. When near a supermassive black hole, time effectively slows down. Time does not exactly slow down, as time is just moving at a reduced rate from the perspective of the person near the supermassive black hole. In simplest terms, due to the intense gravity, the curvature of spacetime is severely bent, greatly increasing the distance light has to travel. If light must always be moving at 300 million meters per second, then the time must be slower as it takes longer for light to move. This is an incredible feat for physics, as this could be used as a way of time travel. The issues with this idea are as follows. The nearest supermassive black hole is around 27,000 light years away, or about 256 quintillion, 126 quadrillion, 455 trillion kilometers, which if you were moving at the fastest speed achieved by humans, which is about 39,897 kilometers an hour, reached by when Apollo 10 gravity assisted around the moon, would take you approximately 732,841,561 years to get to. Obviously, humans do not live this long, and if we were to do a time travel mission, we would need to be moving a lot faster than we are currently capable of. Another issue is that we believe that the speed of light is 300 million meters per second. If this is not true, then all of the scientific ideas we currently believe fall apart, such as general relativity.